Hello friends, today's video will not start with an example or an activity, but rather with a story that changed the definition of science. What happened is when electric current was flowing through a metal wire, the compass kept nearby showed a kind of deflection. Then Oersted realized that electricity also produces magnetic effect. But what is this magnetic effect? Does it increase and decrease with electric current, or is it always constant? Would this magnetic effect be like a magnet or different from it? Similar questions will be emphasized in today's video. So first of all, we need to know what this small round looking device is. This device is called magnetic compass, which is used to find the direction of Earth's magnetic field. Our Earth also acts like a big magnet, which you will study in the higher classes. Also, this compass is used to show direction. The needle of this magnet is just like an ordinary magnet which has north and south poles. The north pole is marked with red color and the needle on this point towards the geographical north pole. As we said that this needle is a magnet. What would happen if a magnet was brought near this compass? They can either attract each other or get repelled. If the north pole of the bar magnet is brought near the compass, it will attract the south pole of the compass towards it. Similarly, the south pole of the bar magnet will attract the north pole of the compass. Let's perform this experiment to understand Oersted's work. To perform this experiment, we need a battery, a piece of thick copper wire, a compass and connecting wires. The battery must be connected to the two ends of the copper wire via switch. Place the compass over the copper wire in such a way that the needle of the compass and the copper wire are parallel to each other. As soon as we put on the switch, we see a deflection in the compass needle. Exactly the same deflection as it was in the case of a bar magnet. We can consider the bar magnet and the current carrying wire to be the same, and it would be fair to say that electricity also has some magnetic effects on the surroundings. If electricity has magnetic effects, then like the magnet, it must have magnetic field and field lines. Let's understand this closely. What will happen if the direction of electric current is changed in the circuit? The deflection of the needle will be in the opposite direction, which means that changing the direction of electric current also changes the direction of magnetic field lines. In order to know the direction of the lines, a little change will have to be made in this experiment. We will keep the apparatus in a vertical direction. Then an emitter must be connected in series along with a piece of cardboard placed around the copper wire with the help of a stand. 4 iron fillings on the cardboard. After putting on the switch and tapping the cardboard twice or thrice, a circular pattern formed by the fillings can be seen. This pattern is nothing else but the magnetic field lines. To find the direction of these lines, a compass can be put on the cardboard. The deflected needle will show the direction of field lines. Hence, it is proved that electric current possesses magnetic fields around the conductor. But if we increase the electric current, then what will happen? The deflection also increases and the strength of magnetic field lines also increases. Also, if we reverse the direction of the current, then the direction of field lines also gets reversed. We have experimented with the increasing and decreasing and reversing the direction of the current. What effect does this change in the size of the wire have on the magnetic field? Let's find out the answer. Take a piece of thick copper wire. See, the deflection has increased with the thickness of the wire. That means the strength of magnetic field lines has also increased. We have learnt a lot of things in today's video. You might find it difficult to remember all the facts. Let's make it easier for you with the help of a right-hand thumb rule. If we need to find the direction of magnetic field lines around a current-carrying conductor, then the right-hand thumb rule will help you. This rule states that imagine you are holding a current-carrying straight conductor in your right hand, such that the thumb points towards the direction of current. Then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. Let's summarize what we have learned today. A current-carrying conductor acts like a magnet. If the electric current is increased, then the strength of magnetic field lines also increases. The strength of magnetic field lines is directly proportional to the thickness of the current-carrying conductor. We will learn about the appliances working on electricity and magnetism in our upcoming videos.